Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 24th, 2025, so it came out just yesterday. This paper shows a striking popularity bias in vision language models, with up to 34% higher accuracy on famous buildings than on ordinary ones, which hints at memorization instead of general visual understanding. The paper is titled Beyond Memorization, a multimodal ordinal regression benchmark to expose popularity bias in vision language models. Okay, and as we go on, the YearGuessr benchmark and the popularity-aware metrics make that bias really hard to ignore. Also, the authors shared a GitHub repo with the PyTorch implementation of YearClip for this benchmark. You will find configs and scripts to train and evaluate, a prepare script for quick setup, and clear pointers for downloading the dataset and checkpoints. The README also explains the experiment folder structure and how to reproduce results. Figure 1 makes the core idea concrete because it shows both what YearGuessr contains and what YearClip produces. This figure shows the full multi-panel overview, including the map, the year distribution, the example record, and the inference pipeline. The left panels highlight global coverage and a construction year histogram. The middle panel lists the multimodal attributes, including page views, as a popularity proxy. The right panel shows YearClip predicting a year plus a short architectural rationale, so the output is checkable by humans. Table 1 explains why YearGuessr matters, because it stacks prior building age datasets side by side and shows the missing pieces. This table shows the full comparison grid across region, year span, size, modalities, continuous labels, images, and whether the dataset is open. The middle columns highlight that many options are regional or mostly post-1900, so they do not test true long-range architectural reasoning. The bottom row emphasizes global coverage plus continuous year labels and open licensing. Figure 2 explains why the dataset is trustworthy, because it shows exactly how raw web pages turn into clean building facades. This figure shows the full 3-panel pipeline, from crawling Wikipedia categories to filtering and auditing. The left panel lists what gets extracted, including page views, which they treat as a popularity proxy. The middle panel shows the dataset shrinking through deduplication, a clip filter, and a human check. The right panel shows examples that get thrown out as off-topic or duplicates, so the benchmark stays focused. Figure 4 shows how YearClip turns an image and optional location into a single construction year, plus a human checkable rationale. The full diagram lays out 4 encoders feeding one regressor, which matters because only the regressor is trained while the encoders stay frozen. The left side shows the facade image and the coordinate input. The middle shows a zero convolution, which starts with zero influence and learns how much the location should matter. The right side shows the best fit style and reason tokens, and the final year prediction. Table 2 gives the headline result that overall accuracy can look strong while popularity bias stays huge. This table shows the full score grid, including mean absolute error, interval accuracy, and popularity split interval accuracy within plus or minus 5 years. In the middle columns, YearClip cuts mean absolute error to about 40 years, while closed models reach about 33 years. On the right, the gain column reveals memorization, because some models jump by about 34 points between low and high page view buildings. Table 7 makes the popularity bias extremely concrete because it reports interval accuracy within plus or minus 5 years across page view bins. This table shows the full grid of methods by popularity ranges, from under 100 views to over 100,000 views. The top block shows clip style baselines, where GeoClip stays relatively stable while clip zero-shot drops as buildings get more popular. The middle block shows large vision language models, where Gemini 2.0 Flash climbs sharply and reaches about 58 in the highest popularity bin. Alright, 2 takeaways stand out. Popularity can inflate vision language model scores by rewarding memorized landmarks, and the YearGuessr benchmark makes that visible with popularity split interval accuracy. The broader implication is that evaluation needs to stress generalization, not recognition, especially for long-tail buildings. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.